student request, I'm now going to continue on to cover material related to test matrices, because this was a point of bit of confusion in the in some of the deliverables, and I'd like to talk about this. So I'm actually rather pleased with what students are giving me about their test. Every group. Good stuff. Good stuff. I'm impressed with it. Some groups have astonishingly large. I was going to say astonishing. Admirably large. Impressively large. Hearteningly large numbers of tests at this point. And I want to see the other groups build up their sets of tests. But I will say that while the information given to me about those tests varies from group to group, there's one thing I want to see in common that's not being delivered by all groups, and that concerns an aspect of what's called traceability. Thanks. So it's the test maker. But I want to highlight it as part of the general commitment or recognition of the value of attending to traceability in product. What is traceability? Well, it's easy. Look, it's easy for you folks to think about projects as consisting of sort of heaps of documents and code and tests and so on. You know, large collections. I even referred to it earlier, right? Give me hearteningly large number of tests. But the fact is, one of the biggest mistakes people make, technically, and in other areas, when you see a system, to focus on the pieces and not the interconnections, to ignore the interconnect. The pieces are important. The interconnections often are the more relevant things you have to understand system behavior and interaction. And this is true in many areas. And software is one of those. Yes, there were tests. Yes, there were requirements documents. Yes, there were design documents. Yes, there were pieces of code. Yes, there are mock-ups. But what's often more interesting and what's often neglected is the connections between these things. Give me one connection between these sorts of things. Like, so I've listed a couple different types of things here. Design components, requirements, text, documentation, code. But well, I think some of those are connected to others. Give me an example. Yeah, I see Alex had his hand, and Connor has contributed outstandingly to the conversation thus far. So I'm going to highlight Alex. Yes, Alex.
I think whereas the code has the test has code associated with it, like, and then code has requirements associated with it, and design. And
often design components, right? They're elements of code that relate to the business logic layer or the design, or there's piece of code in interfaces that relate to this interface in the design between business logic and test or whatever, the test layers. That's right. And so often design requirements relate to design components relate to requirements, right? Documentation on tests relates to tests, right? So these are not solitudes. They're actually interconnected. And this matters. It matters for many reasons, but one of them is that as things evolve, right, as code evolves, can you think about something that might have to change? If you go and you muck around with a bunch of code, what might have to change for it? What else in here might have to change? The text, yeah. Particularly if you're changing the interface to the code, right? If you're saying even at the most basic level, this function takes an extra parameter, right? Or this class has 3 extra methods to it, or I've split this class into two subclasses, but each with better coherence. Tests have to evolve for that, right? If the requirements change, could other things change? Yeah, like everything. But certainly if one requirement changes, it might ripple through to changes in the design, to changes in the code, right? And changes in the test. I made this point probably about 4 weeks ago up around this area of the board, where I drew an exponential graph of sort of how much, if you miss a design change until later and later in a project, often it requires exponentially more work as time goes on to fix it, the later and later you find it. So the fact that these things relate to one another really matters when change is considered. And change is a reality for projects. Things evolve, right? And these changes ripple through it. Now, these changes put at risk the value of documentation, because if documentation on the test is outdated, it's no longer consistent with the test, people won't pay much attention. If documentation on the design hasn't captured the latest changes in the design, it becomes increasingly ignored, right? And so there's a need to think through and to think through what is changed when you change a given component of this, a given component of the system. So there's this term traceability, this commitment to being able to capture those connections within the system between different sorts of artifacts, tests, code, the elements of design, requirements. It's about capturing those relationships, okay? And it helps buffer the project from change, because you know what depends on this thing, so you know what elements of the design depends on a requirement, or what elements of code depend on an element of the design, or what elements of design, what tests depend on a given piece of code. This is not merely like just a fun thing you do in your spare time. Instead, it's something you do so that you can, when you change something, you know what is affected, and you can hop on the task of adjusting those things accordingly. When you change code, you can fly ahead of the plane and start to think about getting the testers alerted, so the testers will modify the code the testers modify the tests that depend on this code. Does that make sense? So you help equip them to know ahead of time these areas of automated tests are probably going to break. And they can start working on those before you dump the new code on them. They can be working on those in parallel with you working on your code. This is an important thing. I mean, you're right now, to quote Cruikshank's words, the words of Cruikshank. We're in the grind part of the semester. Say it like it is, young man. And you've got folks working on code right now, but that code, at some point, it's going to be a feature freeze, right? And they're going to hand that code off to the testers, right? But until then, the testers have some time to get ready. And if they can be alerted to certain areas of the code changing, which will break some of their tests, or which will require tests that they're writing to be crafted a bit differently, you want to alert them to that early. And if you know what tests depend on this code, you can alert them to them, right? Now, this is not without cost, right? I mean, like, you have to do bookkeeping for this. Now, at a level of next generation software development, a lot of this sort of information, the connection between things, will be automated in your professional lifetime. So I'd anticipate a lot of these connections being automated. But one of the most basic ones that's widely used in industry is test matrices. And this is a form of traceability. It's one of these things that links up artifacts, right? That talks about the connection between artifacts. And specifically, this links test cases to the X to which they relate. Now, the X could be modules of code, elements of code, right? It could be features or particular requirements. That varies by teams, and I'm going to let you sort of choose this. This is from Craig and Jaskiel, systematic software testing. If anyone's interested in really thoughtful, good, practical test books, there are some really good ones that I could recommend. Some of them are in the syllabus. But I want to highlight here the form of this testing. The matrices, the columns and rows. The columns of the test matrices are test cases, right? Labeled here test TC 1 through 7. Vertically are the requirements being tested by those tests, or the features being tested by those tests. Now, what's on this axis here? Requirements, features, aspects of non-functional concerns such as performance or reliability differ by test matrices, and I'm not going to be really particular about that. But what's important here is that a given cell within this matrix, in a particular column represented by the test, in this case, test case 2, and a given row, in this case, requirement 2, indicates that test case 2, part of what it does is to test requirement 2. It's not saying that that's the only thing tested by this test case. Indeed, that particular test case, TC number 2, also tests requirement 3 and feature 4. But it documents many of the things tested by this test case, such that if you were to muck with, if the stakeholder needs to change requirements 3 or retracts requirements 3, it's no longer a need, right? Time is too short. We're gonna, it's gotten too complex. We realized we were off base in this requirement. We're going to roll it back. Or if someone changes feature 4 based on usability concerns or based on concerns about, the workflow of the system or what have you, or just as part of the incremental rollout, the test case 2 will be affected. Yes, Jason.
On this test matrix, the requirements and the features are two separate things.
That's right.
On our test matrices, we have like feature / requirements.
That's fine.
Okay, fine.
That's why I said I'm not going to be particular about this.
Okay.
You'll find test matrices differ quite broadly in what they have in the rows, or in the other axis for some test cases. They also sometimes deal with the print code, so test cases on row, and what features, requirements, piece of functionality, elements of design on the columns. But I kind of like test cases on the columns. Amongst other things, we'll often have short names and longer names can be put on the rows. But yeah, I'm not going to be particular about this. Yes, Ken.
Like requirement 1 doesn't have any, so would that be like a mess? Like
Exactly. You got it, Tanner. You got it. You're quite perceptive, and you'll notice that one of the that virtues of these sort of things is that you can spot gaps. So one is you can find particular features that aren't tested or requirements that are not tested by any test case. And that's of obvious concern, right? We need a test case for this. And so it gets you to reflect on like, what do we cover now? But it also can spot issues where there may be a test case, none of them are shown here right now, but where the test doesn't test any current requirements or features, where in short, it's not really relevant anymore, where it's no longer serving a meaningful role. And that can happen. It tends to be fairly rare. After all, the test does something. But it may also be just unnecessary because it's a subset of another test or something like that. That's routinely read. Maybe test A and test B and test C are different, but test D really is just a subset of test A, and in which case you may not need to continue to maintain it. So this can give a sense of what the test cases are testing, right? It can also give you a sense of disproportionate testing, or at least imbalance in testing, right? Like that certain features are only tested by one test, other features are tested by many tests. So this sort of document is really good for reflection on what features and requirements are being tested, on the roles the particular test cases play, on the relative emphasis in the testing, and it's also a good reflection if things change. So if feature 4 is changed, as I argued, you have some understanding of the test cases that the testers may want to start working to refine. Now, this information captured in this test matrix may seem like, yeah, it offers a little bit of value if these are manual tests, right? Okay, we'll have to change the manual test script ahead of time, fine. But if these are automated tests and you change feature 4, they may just like break like that. They're not going to work at all, anymore in the updated user interface because the button won't be there on that screen, or it's changed to a drop down. And you're not going to have the option of like the tester on the fly saying, oh, it's just now it used to be a combo box, now it's just a drop down. I'll just go forward with it, right? You don't have the option of them just fixing it on the fly. With automated tests, generally fixing them is going to require updating the script, the test script, and that's going to take time. It may involve recording a new test script or what have you. So getting these identified ahead of time while the developers are working to roll out the change for feature 4 allows the test team to be busy well before the feature freeze date, starting to modify these. So when they get the new code, they're ready for it with the test updates. Okay. It's also one of the reasons why you might want to think about in your pull request bundling together updates to the test with updates to the features relied upon by those tests, because they are logically linked. They are logically intertwined, right? They go together in terms of if one changes, if the feature changes, the tests need to change as well. Any questions? Yes, Jason.
I'm also just looking at our test matrices.
Mm-hmm.
So we have the different types of like unit tests, integration tests.
Yeah.
The features on each of these type of test matrices seem to be like the same. Would there be any case where one unit or system test would have different features that it would test than
right?
That's what the different features in the unit is.
Yeah, it's good. So often unit tests, it's often harder to, so this is a very good question about kind of test matrices for different types of tests. So those test matrices, are they all gonna have sort of similar left-hand side rows here, or are they gonna differ? And I would say unit tests. You could say that this unit test is involved in validating a requirement, but often this unit test is testing out a particular element of the low-level design or the design of the system. It's testing a certain class, for example, right? Or it's testing a certain method. And then that method may then be used, as something that supports this element of design, which supports this requirement. So sometimes I think for unit tests, you could be excused for having in place here, Jason, on the rows on the left-hand side here, elements of the design and for unit tests, right? When I say elements of the design, I'm talking about, you could say they're elements of the code, but hopefully you've thought through from the point of view of design. So there might be certain classes, or there might be certain aspects of the API that are tested by certain tests. And often those low-level tests are more directly connected with like the technical component, the technical element of the design that they are testing. And so there I might put the elements of the design on the y-axis, the row axis, rather than just like requirement or feature. Because think about it this way: a given piece of code that's more fundamental, like let's say in the data layer, right, of your system, or in the business logic of your system, that might contribute to many features, right? Like the ability to persist something, or the ability for the system to exchange messages with its server endpoints or what have you. Ability to load files, and that might just be involved in realizing many features. And you could put it in this way. It's so cross-cutting. It may be worth thinking about a test for that being stated as just testing that artifact of the design, that particular component of the design. That's all I'd say comes to mind there. There may, Jason, also be, in terms of tests, one type of test that also does not fit neatly into this V model is tests of non-functional requirements, right? We may talk about that in coming lectures. Load tests, stress tests. Load tests would be, for example, testing how does your system behave with very large numbers of users logged in. Stress tests might test your system under very slow network speeds, high memory contention, so low memory conditions, low disk space conditions, cases where the environment is resource constrained. Load tests are very common for web-based applications. You really want to make sure that your system will handle tens of thousands of people coming to it. It's one of the, there are many ironies, ladies and gentlemen. Sometimes many cool slings of fate that we as software engineers need to find. I'm all really dramatic, but hear me out. One of them is, and this is true of a whole class of professionals, it's hard to get credit for preventing fires that never happen. Hard to get prevention heading off problems is something that doesn't get credit in this world. What gets credit in the world is rushing into a fire and saving people after it's occurred. That's where people say, wow, what a hero. The bigger heroes are the ones who prevent the fires from happening in the first place. But they are unseen heroes. They are unsung heroes. And so it is with good software engineering often. The ones who contribute the most are the ones who prevent problems from happening. And, you know, you get similar issues with software design, where you know, sometimes the preventive aspects that are put into place with testing, with peer review, etc., they head off quality problems which are never seen. The person who gets sort of lauded might be the person who pulls a niter and fixes bugs, etc., but it's often heading off those bugs that are the bigger issue. And now, Jason, can you remind me your question?
I guess the question was for
Yeah.
testing matrix, like.
Yeah.
You know,
Oh, yeah.
features and requirements, would
Yes.
they be the same on every type of
Exactly.
system?
Yeah. So, remember that. I thought there was a subsequent question, but a few neurons fired when I was saying that late in the game. So with respect to that matrix, right. Yeah, the non-functional requirements, the issues of load testing and stress testing. Here's the deal. One of the other cruel elements of fate that we as software engineers have to deal with is the time where your system most needs to shine. Imagine you're running a small business, a startup company or whatever, and your product goes viral. Your news to your system goes viral, and there's a lot of interest generated. That's the time you're going to get tons of hits to your system, to your web application, or to your web API for doing some nifty thing. That's the time you most need to shine, but it's the time that your system will be most under stress, most under pressure. It'll have the most users. It'll be under stress conditions because it may be robbed of good enough memory to operate or disk space. And we as software engineers have to plan for those bursty situations where we have huge demand for our system, because that is the time that we, like Saskatoon, must shine. Okay. If we don't shine, then we're going to miss some of the biggest opportunities eventually for realizing our technical dreams, because those are the times we're going to be most in the scrutiny of the world, and we have to hold up. And that requires a lot of preventive efforts with load testing, and indeed, Jason, with stress testing, to be prepared for those eventualities. Unsung, unseen often, unheralded, but heroic. And with that, I will end my lecture. Thank you.